Hello and welcome to lesson 3.6. This lesson is titled The Effects of Alcohol. And today we will be learning about slope-intercept form and linear modeling. This can be found on page 361 of your textbook. If you remember the last lesson we did, section 3.5, we talked about direct variation. And I mentioned at the very end that this was the beginning of our equations of lines. We called it either y equals kx or y equals mx. Today we're going to take a step beyond that and do the slope-intercept form, which adds one little extra thing to our equation. Towards the middle of the page is where the classwork starts. It says a student organization that you're involved in is planning a year-ending pizza party to celebrate another successful year on campus. As chair of the planning committee, you've worked out a deal with a local pizza place to provide 9 pizzas at $9 each. We're allowed to spend at most $175, so we want to figure out how many pizzas we can get. Number 1 asks us to do this just numerically, no algebra involved. So I know that I have $175 to spend. I know that pizzas are $9 each, so I'm going to divide that by 9. And let's throw that into our calculator. 175 divided by 9. I get 19.4, and I can't buy 0.4 of a pizza, so my answer is that I can buy 19 pizzas and stay within my budget. Number 2 wants us to do the same idea, but take an algebraic approach. So they want us to write an equation that represents the cost of ordering P pizzas. Well, I know the total cost will be equal to $9 times the number of pizzas. And then it asks, what does this tell you about how cost varies with the number of pizzas? It tells us that this is direct variation. So that's exactly what we did in the last lesson. We're going to turn the page to page 362. And just like in the last section, we're going to create a table and we're going to create a graph of this stuff. So to complete the table, remember we're using the equation C equals 9 times the number of pizzas. And then you're just going to replace P with each of the numbers in the table. So the first thing I'll replace it with is a 0. So I'm going to do 9 times 0, and I will get 0. I can use my calculator as much or as little as needed here. Next, do 9 times 5. 5 pizzas will cost us $45. 9 times 10 will cost us $90. 9 times 15 is where I need my calculator. So 9 times 15 is $135. And we can continue to put those in our calculator. The next one will be 180. The next one will be 225. And 30 pizzas will cost us $270. And remember, we learned last time how to do this on the calculator. So you could actually force the calculator to create the table for you. Next thing they want us to do is graph those points. So they've got the titles on, which is awesome. The author recommends going up by 2s across the horizontal axis, the x-axis, or the number of pizzas axis, and going up by 20s on the vertical axis. Try to make it thicker so we can get a good size point. I don't do circles well, so if I just use the dot, that works better. And then they ask us to plot the points. So using the table above, we're going to plot those. We know 0 pizzas cost $0, so I put a point right there. And my hand moved, so let's do 1 point, not 2. I'm going to scroll this up a little bit. I write better when the screen's higher. 5 pizzas was $45, so 2, 4, 5, 20, 40. So my hand trimmered again. Sometimes my hand doesn't work well. 2, 4, 2, 4, 5, and then that was $45. And then we know 10 pizzas, so 2, 4, 6, 8, 10 pizzas cost $90. 20, 40, 60, 80, so it should be halfway in between there. 15 pizzas cost us 135, so 2, 4, 6, 8, 10, 12, 14, right past there. And that was 135, so 20, 40, 60, 80, 100, 120, 140, so right in between there. That was, so let's do 20 pizzas. I don't know if you went far enough on this to do that, so we'll see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's the last one we'll be able to do. That one costs $180. 20, 40, 60, 80, 100, 120, 140, 160, 180. And what do you notice about the shape of our graph? If I connected those, it looks like a line. So again, everything we're doing in here is going to be linear. We could also use the calculator to graph this. Number 5 says, since we want to spend at most $175, this might be a good place to use an inequality. Write an inequality that can be used to find the number of pizzas you can buy for at most $175. So instead of saying 9p equals $175, we can say 9p has to be less than or equal to 175. My total cost has to be less than or equal to my budget. Just like with equations, we can solve this by dividing both sides by 9. And I get that P is less than or equal to that 19.4 again. So the same thing we got before, I still can only buy up to 19 pizzas since I can't buy decimal portions of a pizza. Top of page 363, they said, what is the slope of the line we drew? So let's go back and find 2 of the points from the table. I've got the table up in front of me here. It's on page 362. I know that I had 0, 0 in the table. And I had 5, 45. You remember from section 3.1 that it doesn't matter which 2 pairs we use. We can use any 2 points. It should always end up being the same because that's what the definition of a line is. We learned in section 3.1 that we subtract the y values. So we're going to take 45 minus 0, and that gives me 45. Then we subtract the x values in the same order, so 5 minus 0, which is 5. And then we divide those out. We take 45 divided by 5, which gives us 9. It's a number you've seen a few times. What does it represent? It represents the cost per pizza. What is the y-intercept of the line? Well, the y-intercept is wherever it crosses the y-axis. You can either find that on the graph or on the table. On the graph, it's where we cross the y-axis. On the table, it's the number that goes with 0 pizzas bought. So what is the y-intercept in this case? 0, 0. So the y-intercept is 0, 0. And it says, what does it represent? It represents that 0 pizzas cost $0. 0 pizzas cost $0. And that's, again, something I love about this course is it's not just numbers anymore. We're putting value and meaning to those numbers. All right, towards the middle of this page, they change things up on us. They say, nice job, but we forgot there's a delivery charge. There's a $10 delivery charge. So now we need to rework the problem to figure out how many pizzas we can get for $9 a pizza with the $10 flat fee. So the first step is to write an equation. Well, my equation is still $9 per pizza, but I have to add to that the fact that there's a $10 delivery fee. So they're going to charge me $10 to bring one pizza. They're going to charge me $10 to bring 15 pizzas. That's going to change our table somewhat. So now we have to do 9 times the number of pizzas bought and add 10. So if I order 0 pizzas, I'm not paying $0 anymore. I'm paying $10 just for the driver to come say hello to me. Do the same thing with 5. 9 times 5 plus 10. And you can use your calculator for this. It'd be 45 plus 10 is 55. You can do that for all the numbers, and you can use the table feature on your calculator if you like. And some of you may be noticing that how this compares to the original table we had. The original table we had was 0, 45, 90. We've got 10, 55, 100. We're going up by 10. So you could go back to the original table and just add 10 to all of them. Or you can use your calculator. So we're going to get 145 for this one, 190 for the next one, 235, and 280. So just like the table number 3, except 10 more than that. They do want us to graph it again. And he's suggesting the same labels. So using 2 across here, using 20 here. Let's make my pencil thicker. So this time I'm using the table above, and I'm going to scroll up here so I can get the dots a little better. From my table from number 9, I know that 0 pizzas cost $10. So it's halfway between 0 and 20. I know that 5 pizzas cost $55. So 2, 4 right in between, 20, 40, 60. So it's almost a 60. 10 pizzas cost $100. 2, 4, 6, 8, 10, 20, 40, 60, 80, 100. So you can see the line looks pretty similar. We'll do 15. So 15 was $145. 2, 4, 6, 8, 10, 12, 14. And then we're trying to go to 145, 20, 40, 60, 80, 100, 120, 140. So right about here. So if we were to connect these again, you're going to see that it looks like a straight line again, but it doesn't go through the origin anymore. It's shifted up 10. So you can see that it's slightly higher. Turning the page to page 364. It says, write and solve an inequality that can be used to find the number of pizzas you can buy with the delivery charge added now. So I'm taking that 9p plus 10, and I want to know when that's less than or equal to 175. I get a lot of questions about whether it's okay to write 9p plus 10 or 10 plus 9p. You could do it in either order. It works both ways. Let's solve this similarly to how we did equations. My first step is to subtract 10 from both sides. This was back early in chapter 3 when we solved equations. Inequalities are very similar, and for all intent and purposes, we'll say they're the same for now. 175 minus 10 is 165, and then let's divide that by 9. So I get p is less than or equal to, let's see what 165 divided by 9 is 18.3. So with the delivery charges, we can only buy up to 18 pizzas. It basically costs us 1 pizza for the delivery charge. In this situation, does the cost of the pizza vary directly? Let's think back to our definition from the last section. Vary directly has to be a straight line. Okay, this is a straight line. We graphed it. That's good. It has to go through 0, 0. It has to go through the origin. Did we go through 0, 0 here? Did 0 pizzas cost $0? No. They cost 10. So the answer is no, it does not vary directly. And the reason is 0 pizzas cost $10. For this to be direct variation, 0 pizzas would have to cost $0. What is the slope of the line we drew? So let's again write down some of the ordered pairs from that line. I know we went through 0, 10, and we went through 5, 55. You'll notice I often use the smaller numbers. They're just easier to work with. You can use any pair of numbers, and it's good practice to try it with some others. Subtract your y values. 55 minus 10 equals 45. And then let's subtract your x values in the same order. So 5 minus 0, which is 5. And then divide those out. Take 45 divided by 5, and we get 9. There's that number we're seeing all over the place. It's not going to change because it's $9 per pizza. $9 per pizza. The next one's asking for the y-intercept. So again, we can go up to either the graph or the table. I want to know where it crosses that y-axis, or how much it costs for 0 pizzas. That's the definition of y-intercept, is when the first value is 0. In either situation, we know it's 10. So the y-intercept is 0, 10. And what does it represent? It represents the $10 delivery fee. All right, turning to page 365, they have us putting it together a little more for us. So they're kind of making us identify everything we just talked about. They're working us towards what this equation should look like. The slope was 9, the y-intercept was 10, and the equation was cost equals 9p plus 10. This is the slope-intercept form of an equation. We usually call it y equals mx plus b. It's okay to do b plus mx as well. Very similar to the direct variation equation we had in the last section, except we've added a number now in for b. Where direct variation had to be just y equals something times x, this is now y equals something times x plus or minus something else. So this is called the slope-intercept form of an equation. If you've ever had an algebra class, it's one of those things that bounces around in your head and just never really goes away. Let's talk through this example real quickly. They give us a small business has 12 employees, and they're adding 4 employees per month. Well, their slope is 4, that's the change, that's per month. Whenever you see the word per, that's going with your variable, and they started with 12. So that's where they got this equation from, y equals 4x plus 12. It would be absolutely fine to say y equals 12 plus 4x, if that makes more sense to you. Some people like to say start with the starting value and then adding 4 each time. Slope, when it's a whole number, is 4 over 1. That's important to think about when we're graphing it. And they actually do a graph of it here. They found points. You could find points, or you could graph the y-intercept and graph it. They show you a nice table here of how they plug the values in. So after 0 months, they had 4 times 0 plus 12. They still had 12 employees. After 1 month, they had 4 times 1 plus 12, or 16 employees. After 2 months, they had 20 employees. So it's a nice worked out example for us. They do show us in this purple box how to graph an equation in slope-intercept form. So if you don't want to find the points, you can graph the y-intercept and then use the slope to go up and over to find another point. So this is the end of the slope-intercept section. The next section we'll look at after this in section 3.7 is point slope. It'll be the last form of an equation we do. Your group work will get you some more practice with working with slope-intercept form. Get comfortable with it because the hardest one's coming up in 3.7. And that will be the last of the equations we do. I hope you have a wonderful day, and I have enjoyed having you.